Rewrite as an exponential equation. Sorry that my handwriting kind of sucks today. I'll work on it. If I were to rewrite this as an exponential equation, what would be my base? The 7, right? This is the base. What would be the exponent? The x. Anything that's on the other side of the equal sign. And I set that equal to the a value, which is y plus 4. Didn't have to solve it, just had to rewrite it. So that's what you should have. Raise your hand if you got that. Cool, some of us didn't even start it. Please make sure you're working. Number 2 then, rewrite as a logarithmic equation. Okay, so this is the same way, it's just going the other way. Okay, so I write the word log, that's going to help me out. Then what? What's the base going to be? The y, because that's the base of your exponent. The a value would be 42, because that's what's on the other side of that equal sign. And then we set that equal to our exponent, which is 7x. Good deal. Any questions on that? Okay, so what I need you to do, I need you to make sure you have those written down somewhere, and I need you to star them. These are the very first 2 questions of your quiz next class. It is a 5-question quiz. They are just like this. They just have different numbers. So out of those 5 questions, those should be really easy points. Okay, just knowing how to rewrite in those forms. All right, we're going to get going. So last class was 5.3 and we talked about exponential equations. This is going to work very similar, except for now we're going to be dealing with that other form, which is logarithmic equations. Okay, if I go back to exponential, and you don't necessarily have to write this, but you can. Okay, so let's say that for instance I had 2 to the x power equals 2 to the x, let's do 2x. 2x plus 3 power. Anybody remember how I would solve that? Say what? Set the exponents equal to each other, right? Because I have the same base on each side and just one of those bases. You with me? So I could set x equal to 2x plus 3. Solve that. X would end up being, subtract 2x, negative x equals 3. So x would be negative 3. And that's it. I was done, right? Okay, I would need a real quick check for extraneous solutions, but we'll talk about that later on. But this is going to be the same idea, okay? But if I am dealing with logarithmic, it's just going to be in that other form. So if the logs have the exact same bases, same deal, but we know that's written as like the little number next to the log, right? If they have the exact same base, I can just set their a values equal to each other and solve. So for instance, on number 1, we see that both of them have a base of 5. Is that the same number? Duh. Okay, so we set these a values equal to each other. Can I solve that equation? Yeah. I would hope so. Okay, subtract the 5x over. 9 equals 1x. That's it. That's my answer. Not too bad, right? Try number 2. Okay, what do we do? Set them equal to each other because they have the same base. We're able to do that, okay? How'd you solve this equation? Plus the 4n, I like it. Move the smaller one, it makes your life easier. So we end up with 1 equals 6n plus 43, then what? Minus 43. Negative 42 equals 6n, so n is going to be negative 7. Raise your hand if you got that. Good deal, we're all on the right page. Okay, that's the easy stuff, right? Just like the exponentials, we started off just like that, okay? Then it's going to start to get a little harder. We're going to go ahead and skip number 3 just because we've done enough of those, okay? If you remember with exponentials, we would have an expanded form on the left and maybe an expanded form on the right, okay? And we'd have to condense each side before we could solve. Same thing here, okay? So if we look over here on the left, I can't have 2 logs, I can only have 1. I notice that both of those logarithms are separated by a plus sign, and I need to convert this to multiplication, right, to make it 1. So I just keep that log. I multiply these a values together. If I had a base, I would write that base, but in this case, the base is 10 because it's not written. So this is the same thing as log base 10 of 4 times y plus 5. I could write it as y plus 5 times 4, but technically this is the prettier way to write it. Equals log of 72. Now I have one log on each side, right, with the same base. So I can just set their a values equal to each other. And just like Catherine said, we just have to distribute and solve. So this 4 goes to the y, goes to the 5. So 4y plus 20 equals 72. Subtract the 20. 4y equals 52. Now what? Divide by 4, and 52 divided by 4 is 13. That's it. Questions on that? Not too bad, right? Okay. Basically, this whole day is just going to be reviewing those condensing properties on each side and then solving. So it's just going to keep getting gradually a little harder, but we've already seen these. So really, this isn't a whole lot of new stuff today. Okay? If we are condensing, and that's one thing you might want to write to the side. So when condensing a side, start with power rule first. Okay? Then you want to deal with your multiplication, division, right? Whichever one comes first. So that is a good way to look at it, okay? So if I notice, do I have a power rule on number 5 on either side?
Yeah.
Yep. What is my power? 3. So if you remember, this is the power on that logarithm. So this is the same thing as log of 7 of 4 to the 3rd power equals log 7 of 4a minus 8. Do I have one log on each side with the same base and I've got rid of my power rules in multiplication and division? Yup. Don't see any more of that. So I can just take those a values, set them equal to each other, solve that equation. Be careful with those power rules, okay? That is not 4 times 3, that is 4 to the 3rd power, which is going to be a lot bigger than 12. What is it? 64. Equals 4a minus 8. Add the 8 over. 72 equals 4a, and you said a equals 18. Cool. Questions on that? Okay, so let's look at what we got left here. I want you to try 6, 7, and let's do 8. Yep. Making good time on this. So 6, 7, and 8. Go ahead and give them a go. Pay attention to what you've got, though. We haven't seen division yet today, or I just gave it away. We haven't seen subtraction yet today. What does that mean to do? Divide. Okay, cool. I'll give you a couple minutes. Work with somebody around you if you'd like. Okay, we start. How many logs on each side do I have? 2 on the left, right? 1 on the right. Do I have any power rules? Don't, but I said I had 2 on the left, right? So I need to condense those. What rule am I going to use? Division, quotient rule. So this is going to become log of 4. 68 divided by 4. It is very important with division that you keep them in the same order, okay? So it is going to be 68 divided by 4 because that 68 came first. Equals log base 4 of 3n plus 11. Do I have 1 log on each side now?
Yeah.
Yes. Got rid of all my rules. Okay, so now what is my equation?
17 equals 3n.
Where'd you get 17?
68.
Yep, you can go ahead and simplify it there. Good deal. So then you did what? Raise your hand if you got that. Cool. All right. Good deal. Anybody have a question on that before we move on? All right. Number 7. What comes first here? Power rule. Where's the power? The 1/2, where's it go? To the 25. Log of 6, 25 to the 1/2 power equals log 6 of 23 minus 4w. Now we do what? Yep, 25 to the 1/2 is what? 5. Same thing as square root of 25, right? So 5 equals 23 minus 4w. Subtract 23. W equals 4.5. Raise your hand if you got 4.5. Okay. Questions on that? Am I going too fast? Do I need to slow down a little bit?
So you don't flip the fraction whenever you move it over?
Don't flip the fraction whenever you move it over. Nope, it stays the same. Don't make it a 2. Yep, don't change the powers.
Okay.
Are we all good on how to type 25 to the 1/2 power in a calculator?
Yeah.
Okay, we should be. Cool. Number 8. Question for you. Do you see a power here? What is it? Where's that going? To the 6. Is it also going to go to the 4? No, why not? Not in parentheses, it's on the other logarithm, right? So the only way you'd square that 4 is if there was a 2 written right here. Give me 1 second. So we said the 2 is only on that first logarithm. So what do? Okay, so we, hold up a second. Yep, we got 6 squared here. Okay, minus log of 3 of 4. So first thing we did was get rid of that power rule. Okay, we still don't have 1 log on the left and 1 log on the right, do we? No, what do we need to do? Division. So this is going to be log base 3 of 2p minus 5 equals log base 3 of 6 squared divided by 4. Good. Get rid of subtraction with division. Now are we able to set up an equation? Yes. So the left side's just going to be, and the right side? 9. So 6 squared is 36. Divide that by 4, you get 9. Cool. Now what? Plus 5. 2p equals, p is 7. You got that one done? Yeah. Okay, cool. All right, any questions before we move on? Cool. Okay. 9 and 10. So we'll start off with number 9. Do I have 1 log on each side? No power rules? Yup. Okay, so I'm ready to start my equation, right? You got it. M squared equals 18 minus 7m. How do I solve something like this? Yep, everything's got to go to the same side. So I would keep this m squared on the left and I'd move everything over just so that stays positive. So I'd add the 7m and then subtract the 18. But you could move the m squared over. You just have negative m squared minus 7m plus 18, which is the same thing. Okay. Now what? X method. We got factoring coming back, unfortunately. What's going to go on top? Negative 18. What's going to go on bottom? 2 things that multiply negative 18, add to 7. 9, negative 2. We're getting fast at those. Good deal. Will the shortcut work? So m minus 2 equals 0. My 2 values of m are negative 9 and 2 if I set both those equal to 0. Okay? Questions on that? So that's tying a little bit of Unit 6 in with Unit 5. Sorry. I'm just kidding. It's not my fault. You can't blame me. I didn't do it. Okay. Number 10 is going to work very similar. Do we need to do another one or are we good?
We're good.
We're good? Okay. So, what we just dealt with, and I need you to agree with me. Can everybody give me their attention?
Yeah.
Carter, TJ.
Sorry.
Okay, I need you to agree with what I'm about to say.
Yeah,
What we just did was 1 log on the left equals 1 log on the right, correct?
Yeah.
Which was why we were able to get rid of the logs and set the set the a values equal to each other, correct?
Yeah.
Okay, so the second thing that we're doing today, and then we're going to be done. This is when we have a log on one side and something else on the other. Okay, so there's not going to be a log on the other side. Do we see that? Yeah, unfortunately there's not, okay, which kind of sucks. But we need to make sure that we condense, okay, when we can, but we also isolate when we can. Okay, so for instance on number 11, the left side is already condensed, correct? It doesn't have any power rules. It's got a base, it's got an a value, it has nothing else hanging around it. And it's set equal to the right side, which is just a number. Okay, so this is going to be something that we've kind of already seen before, where we take our base, which is 2, we take it to the power of whatever's on the other side of the equal sign, so in this case 6, and we set it equal to the a value. Are you with me? Okay, can we solve something like that? Yeah, that's not bad. We just got to remember how to put it in that form. That's the hardest part. So tell me what 2 to the 6th power is. 64 equals x minus 4. Then you got it, plus 4. X is 68. Good deal. I'm glad you think so. Okay. Now we're going to real quick move over to number 12. Don't freak out. You got it. So you see how 12 has some friends hanging around, right? It needs to be the log and its a value needs to be on a side by itself, okay? But that 7 cannot be over there. So we've got to add that over. Good deal. So log base 3 of 4x plus 8 equals, what's negative 3 plus 7? 4. And now set this up for me. 3 to the 4th. 4x plus 8 equals 4x plus 8. Good deal. So what is 3 to the 4th?
81.
81 equals 4x plus 8. Okay. When you subtract the 8, you get 73 equals 4x. And what is 73 divided by 4? 18.25. I like it. Good deal. Decimals work. If your calculator gives you fractions, that's fine too. I don't care. Okay? $13. Rut-row. Do we have one log by itself on a side set equal to something else? Multiply them, right? This is product rule. Okay, so this is the same thing as log of 2x times x minus 5 equals 2. Yep, you could go ahead and distribute now if you want to, or you can wait. You can go ahead and put this into exponential form. Okay, but tricky. A lot of us got really confused on that first quiz with no calculator on what to do when there's no base written. And I know we know what it is, but we just freak out and we pretend that we don't know what it is. What is the base if there's not one written?
10.
It is 10. So even if you need to get in the habit of writing that in there sometimes, do it. Okay, so this is going to be the same thing as 10 to the 2nd power equals that a value. So you could go ahead and distribute it now if you want to. Equals 2x squared minus 10x, right? See what I'm doing?
Wait, what happened to 2?
It's the power. So whatever's on the other side of the equal sign, that's your exponent. Yep. Okay. So what is 10 squared? 100 equals 2x squared minus 10x. This is going to be kind of similar to one of those other ones that we did. How do we solve this?
Plus 10x plus 2x squared.
Subtract them.
We could factor.
We're going to end up factoring, yeah. But I would subtract the 100 over just because the leading coefficient, which is the highest exponent, is already positive, which is why I would move the 100. Okay, but you're good to move them to whichever side you please, as long as you use inverse operations. So if it's positive, you subtract it over. If it's negative, you add it over.
Take out a 2.
You're going to take out a 2? Okay. When you take out a 2, what's going to be left, TJ?
X squared minus 5x minus 50.
Cool. Can we factor that? Yeah. Try X method first. What goes on top? Negative 50, bottom. Negative 5, two things that will multiply to negative 50, add to negative 5. Ooh. Negative 10 and 5. Will the shortcut work? But I have to remember to keep my 2 out front. Cool. 2 times x minus 10 times x plus 5 equals 0. Then I just set every part equal to 0, right? Can 2 equal 0? No, it can't. So that one's not going to work. Can x minus 10 equal 0? What would x be? And can x plus 5 equal 0? And x would be negative 5. Those are my 2 answers. So it's okay to get 2 answers on this. Once you've got it in that other form, your highest exponent typically is going to be how many answers you have, unless for some reason it would cancel out with a different number, okay? Which is not going to happen too often. But how do we feel about this?
Good.
Feeling okay? Okay, I want you to do, let's look here. Try number 14 and try number, you want to do 15 or 16? 15, cool. Let's do 14 and 15. Go ahead and try those. Let's do number 14 since we're all confused. Okay, I need to have no power rules, and I need one side completely condensed, right? I need a log on one side and everything else on the other. Are you with me? Okay, cool. So first things first, get rid of any power rules that you see. The 2, where's it going to go? To the x. I think a lot of us, the reason that we are getting confused is that we're trying to skip steps because we're trying to get this done as quick as possible. Let's not do that. Okay, so write out each step. Now I look. Do I have one log on the one side? No, I need to have 1. How do I condense that? Division, right? Quotient. Good. So I divide. What goes on top? Over 4 equals still the 2. Now is this in a form that I can deal with? Yeah. What is the base on this one? Be careful. 10, because it's not written, right? Okay, so now I write this in exponential form, and how do I do it? Okay, good deal. And now we simplify. Yep, you can multiply by 4, but I would first do that exponent. So 100 equals x squared over 4. Carter told us to multiply by 4. What is 100 times 4? 400 equals x squared. Now what? Square root. Or you could subtract the 400 over and see a difference in squares, right? But if I square root, I have to know that the square root of 400 is, and what else? Negative 20. Okay. Another thing we could have done is subtract that 400 over, so it would have looked more like this. And then that would help me remember, okay, x minus 20, x plus 20. You with me? Same thing, okay? That's how difference of squares works. 15. What'd we do?
I don't know, I didn't get that far.
Log 6 of x plus 9 times x. You could write it in whichever order. I would probably put the x first, just because it's prettier that way, and it tells me I definitely need to distribute if I don't remember to do that if it's on the left. But either way, as long as you knew. So now I do what? 6 equals X squared plus 9x, I like it. What is 6 squared? 36 equals x squared plus 9x, now what? Subtract 36, so 0 equals x squared plus 9x minus 36. Will that factor? What are the two factors? Okay. And my answers? Bingo. Cool. Yes? Yes, yes, yes.
Yep.
Questions? How are we feeling on a confidence level of 0 to 12? 12? Okay. Did you say 2? A 2? Green light? Green light. Okay. Last page. Natural logs, remember, these are just like regular logs. The same rules. Natural logs are just like regular logs except for A, they are healthier, right? Because they're natural. And B, they have a base of
10.
what letter? E. Okay. Cool. All right. Number 17. I look. What do you see here? 2 natural logs on opposite sides of the equal sign, correct? 1 on each side. No power rules? No. So what can I do here? Yeah, just set the A values equal to each other. So same thing as logs, okay? If it's on both sides, we can do that. If it's on both sides, we can do that. So now what? Minus 4n. Negative 7 equals negative 7n. So n equals what, Tate?
1.
Bingo. N equals 1. Okay, so again, just like logs, if it's on both sides, 1 on each side, we've condensed already, we can set the A values equal to each other. Do we see natural logs on both sides here? Uh-huh. So is this going to work the same way as what we just did? Yeah, but we just need 1 log on each side. Do we have that? No. What do we have?
2.
We have 2 on one side, so what do we do about it? Multiply them, because it's a plus sign, right? So this is going to be natural log of 2x times x minus 7 equals natural log of 4x. Now what? You can distribute. Can you set up your equation now? Yep. So distribute 2x squared minus equals 4x. Good. Subtract 4x. 2x squared minus 18x equals 0. Factor. Yeah, this is a GCF one, right? Pull out a 2x. What's left? Okay. Set both factors equal to 0 and solve. X equals 9 and? Nope. What's 0 divided by 2? 0. 9 and 0. Okay. Fun stuff, right? Yeah, very fun. Love it. Ooh, number 19. Logs on both sides. No, 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 no. There's not. Okay? But the side that does have the log, is it alone? Does it have any friends hanging out in the front or in the back? No, it does not. So does that mean we're ready to set up an equation? Yes. Okay, think back. If it's a natural log, we said it's healthier and it also has a base of e. So if I set this up, it's going to be e to the second, because that's what's on the other side of the equal sign, equals 14 minus 5n. Can I do e to the second in my head?
No.
Absolutely not. You cannot. But can your calculator do it?
Yeah.
Yeah, it can, and we actually haven't talked about this yet, so grab a calculator. If you don't have one, this would be a good time to come grab one. I'm not going to throw my calculators across the room, no, but you can come up here and grab one.
Yep, what she said.
Okay, so it seems like everyone's found the button, but if you have not, it is the natural log button on my calculators, but you have to hit the second button before you click it. E to the caret, you would type in 2. I would round it to 3 places, so that's going to give me 7.389 equals 14 minus 5n, but am I done yet? No, I don't know what n equals. Yep, minus the 14. So what is 7.389 minus 14? 611 equals negative 5n. And lastly, we would divide that by the negative 5. 1.322. I like it. That's my answer. You don't like those decimals? They don't like you either. Just kidding. They do. They love you. Okay. That's it for today. How do we feel? Again, rate. Let's go from 0 to 10 this time because that's more normal. 9-ish, 6-ish. Orange, purple, green light. Cool. Okay. I like it. If you have questions, let me know.